All right, let's learn about inequalities. What are they? Inequalities are mathematical statements or sentences that include an inequality symbol, which are these guys. Maybe you've seen them before. Basically, everything that's not an equal sign in an expression. And they basically mean smaller than, or less than, bigger than, or greater than, not equal or different, and then smaller than or equal, or less than or equal, and greater than or bigger than or equal. And solutions for inequalities are any number that makes the inequality statement true. So, for example, if you have a inequality that says y is bigger than negative 2, what number could be a solution? Well, any number larger than negative 2. So all you have to do is find negative 2 in the number line and think of any number that's bigger than that. Well, those will be the numbers to the right of it. And so negative 1.9999999999999 would work. Very close to negative 2, but a little bigger, right? Negative 1 would work. Negative 1.5 would work. Negative 0.5 would work. 0 and 0.5 and 1 and 2 and 3 and 4 and 5 and 6 and every other number to the eternity as long as you go to the right. But if you try to include negative 2, that wouldn't be true because negative 2 is equal to negative 2. So that couldn't work. Or any number below negative 2 in the number line also would not work. That's basically the nature of what inequalities are like. So let's see some other graphical examples of how to think about this. So here's some examples. We have A is smaller than 4. What would that look like? Could you include the 4 in the answer? No, because 4 is not equal to 4, right? It is equal to 4, sorry, I meant. And so you can't include it. Because of that, you put an open dot next to 4 to symbolize that you should not include 4 since it is equal, not smaller than 4. And because we're looking for smaller numbers, we're going to head to the left for all the numbers that are included. And therefore, we shade all of those. Likewise, with b bigger than negative 3, we can't include negative 3 because negative 3 would be equal to negative 3. But we're looking for numbers bigger than that. So we go to the right in the number line and shade all the points to the right of negative 3. So hopefully this makes sense. Let's see a few more. So in this example, we're looking at C is smaller than or equal to negative 1. Now, this time we have the equal side, which means we can include the negative 1. To show the negative 1 is included as a possible solution, this time we use a shaded dot because a closed dot symbolizes that the number 1 is part of the solution. And we're once again looking for numbers smaller than that, and so we're going to go to the left and shade all the points to the left of negative 1 as part of our answer. Be careful with this next one. We're looking for negative 2 and every number smaller or bigger than that. Well, let's think about it. Negative 2 has the bigger than sign next to it because it has the big mouth next to it. That means negative 2 must be bigger than our answers. So we're looking for things smaller than negative 2 since negative 2 must be bigger than them. But we can include it because there's an equal sign. So we once again shade negative 2 to symbolize that we can include it. And then we go to the left because negative 2 must be bigger than our answers. And so we shade everything to the left of negative 2 as a graphical solution. So on the next video, we're going to see some more examples of this on a whiteboard, going either from graph to solution or from solution to graph or to inequality. And I'll see you guys then.